to set the destination, but this is a demonstration. So the destination, a starting point and destination, and how to go through this track is already set in the computer.
Okay.
So the next step, we just start button to start the autonomous driving. Okay. And so once we start the autonomous drive, the LED is mounted here, steering wheel, and it turns on blue. Now, while the car is driving as it planned, that LED turns on blue. But if there's some cars are coming from in front of this car, or some cars are parked in front, the colors change red, and they start to judge how to maneuver under the situation. Okay? それじゃあ出発します。B モードでお願いします。Okay, so what I have to do is push this button. First, here's a stop sign. The car stop. When it's clear, and stop. The next, make a right turn.
How is the car detecting to stop? Is it looking for the line on the road?
Right.
Or is it programmed to stop?
No, the car detects the white lines to detect its position. And also this car has the precise map of this route, so that the car matches the map's information and the camera's information, so it can understand where the car is driving now.
So when you say it's an accurate map,
Right.
or a detailed map, how detailed would it have to be?
Well,
Like within 3 feet of, I mean, what kind of resolution would you need?
yeah, at least we need the resolution to understand, distinguish the width of the white lines, such as resolutions. Also here, the car detects the blue cars, so that the car judges to wait here until it's clear, and then go.
It's using a laser scanner to detect.
Right. So you can see that the blue points
I see.
are the detect of the registers. So then
Normally people's morning commute is not through a convention center.
yeah. So this situation, the parked car. So the car judges that car will not move, and there's no other cars coming from the opposite side. So the car judges to start to overtake and go back to the original way.
So for this demo, could it go faster, or are you limited to about 15 miles per hour?
Yeah, this demo I limited its speed because of the safety.
Sure.
Yeah.
But
this car had the potential to speed accelerate up to 70 kilometers per hour.
Oh.
Yeah, we already done around the 45 and 50 miles per hour at the test track in Nissan.
So are you getting tired of going in circles?
Yeah, sometimes. So next time this goes.
That's really interesting.
Here.
So now, was Nissan involved with the DARPA challenge?
No. Yeah, this time the other cars also coming, but that is too slow. So car judges that we can go first to go into the intersection.
So can you give the car an attitude?
Yeah.
Like it tries scaring the other cars into submission? So do you have anything where vehicles can communicate with each other?
No.
So like I sense this other car and working towards some sort of between car communications tech.
Yeah, I think that's a very good way to communicate and more safe. But at the time, we didn't have such kind of communication devices in this car. Okay, so there's a destination. So car will go over here. So stop. and change its shift to the parking. You can see.
Mm-hmm.
So you can go out.
Ah, yeah. Thank you very much.
Great. Thank you.
Thank you.
Okay, so this is what this looks like from the outside. So if I stand in front of the car, will it run me over? Or will it detect me? And
We could try. Sorry.
Oh, I understand. So
皆
here,
様にご案内いたします。この後3時30分より日産自動車の自動運転車オートノマスドライブによるデモンストレーションを行います。皆様どうぞお集まりください。繰り返しご案内いたします。この後3時30分より日産自動車の自動運転車オートノマスドライブによ
so
る
here they
デモン
go.
ストレーション
They're going to start driving. See, everything turns blue. So it's using the white lines as guides as well as laser vision. So shortly they're going to bring another car out for it to detect a possible collision pattern or a collision vector. Notice that the lights have turned red underneath, which means it detects a vehicle that is passing in front of it. It'll turn blue after it has passed well enough. Note that the other vehicle is not autonomous. Now when we go back again, you'll notice that they're going to bring this other car around so that the car can determine the right of way. It does notice that the other vehicle is stopped. It still needs to stop at a stop sign. I'm sorry, there's a stop sign there. Yeah. Now, they're going to bring this car around so that we can see an example of it determining which car has the right of way. Now it's going to notice that it can go because it realizes that there is a stop sign there. So it continues. Again, right of way. And there you have it, another successful demo of the partially autonomous vehicle. Okay, so here's the Q&A regarding the autonomous or partially autonomous vehicle right now. So what happened if you, or what would happen if you went slightly off plan? So the gentleman in the blue car, let's say he decided to run the light. Would the current version have stopped and recognized that, or recognized that and stopped?
Yeah. Can I understand that how the blue car will move? So if there's a danger situation, car judges to stop. But there's no danger situation. Car is still keep going to its original route. So if there's no blue cars, the autonomous driving will never change its light to red.
Oh, okay.
Yeah.
So in inclement weather, and let's say
Well-
the lines were, hard to see.
Right.
What would happen? Does it fall back to another system, or
Well-
at that point it just pulls over and says, "Please wait"?
Yeah, at the moment we have to think about such kind of things. We haven't had that good solution yet, so that we need to work such kind of things.
Oh, okay.
One of the solutions is that of course we are not the electronics makers, so that we don't make the cameras.
Right.
But we can combine many type of sensors, so that combining many type of sensors, data, so in the future car can judge what the car is driving now or the danger situation.
Ah.
What
So-
sensors have been added to the car?
Pardon, sorry.
What sensors have been added to the car?
Well, at the time we have 5 cameras and 5 laser scanners.
Okay. What direction? So forward, back, left, and right. Where's the fifth?
Yes, 360.
Okay. Why 5, not 4?
Well, we need more precise information, especially from front.
Okay, so just in front.
Right.
So do you have ultrasound sensors for very close proximity?
But
Do you have ultrasound sensors to detect, for example,
Ultrasound?
ultrasound?
Ultrasound.
Oh,
Yeah.
sorry.
Ultrasonic.
Yeah, at the time we don't have ultrasonic sensors.
Because it's for when, let's say, if children are going by
Right,
behind.
right.
Okay.
Now,
Yeah, but actually our system have the around the monitoring cameras, so that the car detect the around the cars by the cameras.
But it works only if the light is good enough.
Oh well, yeah, that will be the problem. So the ultrasonic sensor is also the good solution.
Okay.
It's not expensive, I think.
I thought last year you were using LiDAR. So are you no longer using LiDAR
Well, LiDAR is almost the same as the laser.
as a laser?
Yeah.
Oh, okay. I thought it was
Scenarios
specific.
like a very busy roundabout, which requires a certain level of aggression to actually get into. Does the logic handle that?
Yeah, that kind of thing is we also trying to explore, but we need some technologies about detecting lots of cars, and have to let the car knows the rules of how to go through the roundabout, because there's no roundabout in Japan.
Right.
Yeah, so we need to do such kind of work in the future.
So are the technical limitations simply software? Are they processing?
Well, I think both
この後3時30分よ
have
り
the limitation,
日産
and
自
we
動車
have
の
to
自
struggle
動運
both
転車
sensing and
オ
hardware
ートノマスドライブによる
technologies
デ
to
モンストレー
develop
ションを行います
good, more make a
皆様どう
good
ぞお集ま
performance
り
of
ください
driving in the future. Yeah.
繰り返し
So
皆
now-
様にご案内いたします
Now that you have the,
この後
now that you're allowed to have it on the
3時30分よ
road
り
to some extent in
日産自
Japan,
動車の
are
自
you?
動運
Is there
転車
some data aggregation
オートノマス
solution?
ド
So
ラ
are
イブ
you
による
grabbing all that
デモン
data,
ストレーションを
all
行います
that small number of cars that's allowed on the road, and then using that to further improve the?
Right. that will be the first way to develop our sensor systems.
Oh, okay. So does it transmit that in real time, or are you just having the users of those cars
first-
and check in once in a while?
Right. First, we record those data, and
But in
also-
real time, like you can watch them in real
yeah,
time.
yeah.
Oh, okay. So do you envision where someone else could kind of take over?
Mm-hmm.
So if you're driving along and you're having, I don't know, difficulty getting the car to do what you need to, or it doesn't seem to be working well in inclement weather.
You mean
Could
it's
someone
like a
take
hacked-
over remotely to fix it? To get
Yeah.
you out of the the
Yeah, I heard
situation?
that. Recently, such kind of some of communication devices have such kind of problems. But we have to more, deeply think about such kind of thing in the future.
Okay.
What's the biggest challenge when it comes to? I mean, I'd imagine that there could be like a problem with congestion if there was a lot of cars with it. I mean, what kind of is there anything Nissan's working on to kind of speed it up, kind of thing? That kind of notion.
Yeah. You're right. It's in the real world, it's a very complicated situation. Many. So that we need more sensor powers to detect more cars more accurately, and also we need to breed the car to know more about what kind of situation.
So it's like an information
Right.
database to
Right.
So what's the sampling rate of the data at the moment?
Well, I think we had multiple, sensors, so that depends on the sensor's output. For example, the laser scanners have almost about 50 Hz and 25 Hz, and the camera has a 30 Hz. Such kind of rate.
So how fast can you drive safely?
Well, at the time we tried to speed up to 70 kilometers per hour on the test track in Japan, in Nissan's test track.
So do you have a theoretical limit?
Well,
Or, like it's safe up to 70 kilometers, but hey, we've had it at 150?
well, yeah, I think it's we need a more high-speed rate processing unit to drive a more high speed.
So what kind of processors in there now? What are the speeds?
Well, yeah, we're basically using it's not so special one. Yeah, it's like computers.
It's
Okay.
like a PC type of thing?
Yeah,
So are you running Linux, Windows?
yeah, such kind of things.
It's what?
Well, yeah, we
Is
need
it,
a
it's
many
custom?
kind of. Yeah, it's the same as the NX on the Windows 8. Yeah.
Oh, okay. Oh, so you're using Windows 8?
Well, yeah, part of the system has the Windows 8.
Oh. Huh. Hey, it brings new meaning to the term metro, right? Huh?
I think Windows system is not the perfect one because it has have the real-time processors.
Right.
Yeah.
Have you looked at QNX?
Sorry, I don't know about the QNX.
QNX?
QNX. Well, yeah, I heard it, but we've not tried it yet.
Or Wind River or whatever. Yeah.
All right.
Cool.
Thank you very much.
Thank you very much. I'm gonna go try this is me trying a Toyota Winglet. So this should be interesting.
And it's my favorite color.
安全が確認できるので赤い光が点灯します。この自動運転車に目的地を設定し、自動運転ボタンをスタートさせると、ハンドルの車の下が青に光り、自動で走り始めます。止まりの標識を認識し、交通ルールに従って一旦停止のボタンです。交差点周囲の安全を確認し、通過できると判断すると、走り始めました。
Just like your Segway.
That's right. Oh, that's good. Oh, it's slipping. Yeah. And go
この自動運転車オートノマスドライブは一般道を使う日常的な目的化した高い知能を持った車です。
Oh, okay.
再び放送にですが、左側の車内先にやってきています。こちらはドライバーの運転する車、有人間のボンネからの安全面です。有人カーを設置し、赤 に点滅しながら停車しました。
Yeah, you have to lean into it. Yeah.
ドライバーを運転されている方は先にスタートします。続いて自動運転車が走行し始めます。相手を先に行かせようと判断したようです。さて、この先に駐車車両がいるようです。今度はどのように対処するのでしょうか。まずは一旦停止しました。辺りを伺っているようですが、行けると判断したようです。光が青に変わって駐車する車が追い越していきます。まるで人が運転しているようですよね。ただいまこちらでは日産自動車の自動運転車オートノマスドライブによる自動走行デモンストレーションを行っています。皆様どうぞ今一度モニターに出ている車内の映像をご注目ください。
Awesome. Woo! 3D.
ハンドル操作もアクセルやブレーキのペダル操作をしながら走行を行っていません。車が自動運転で走行していることを確認いただけます。
Oh, I see. That's how we do it. Well, it's weird because, like, on a Segway, people think that they should move like this, but actually, it's all about shifting your weight, and then this does this.
Like what?
So you just need to learn to use that. So
It's easier or
it's just as easy, but it's not the same. Like going backwards, I can go backwards on a Segway, but you wouldn't want to. So same thing with this. It encourages you not to do that because you will fall if you're not careful. Very nice. Very nice.
いかがでしたか。相手の動きを読むというまるで人間のような知能を持った車。私たち日産はこの自動運転技術を進化させていくことで事故ゼロという究極の目標に挑戦していきます。そして2020年までにはこの技術を商品化し幅広い車種に適用していくことを目指しています。
All right, I get this. This is cool. So these you can buy them now, right?
yes?
Yeah. How much are these now?
買えないです。今はまださっき
What?
スペルで
Oh, it's just experimental. Oh, okay. I thought they were going to be available by now.
今もう買える
When?
How much do you pay?
It'd probably go for $2,000, but yeah, I would say $995 would be the magic number for me. $1,000. I would pay $1,000 for this. I don't think I'd pay $2,000. But that's because I'm going to Segway, and those were $5,000. So,
5,000